So, thus far, we've talked about all the properties of atoms now. We've talked about how we sort of diagram out the electrons. And now you guys understand, hopefully, based on what we talked about in our question of the day, how things form compounds, and starting to understand why we have different ratios, why we have different numbers there that make up a compound. And so today we're going to talk about how we actually figure that out in a simple way. Okay? You don't have to draw out the electron diagrams every time to just figure out the formula formed by a compound. Okay? And so we'll start with a simple example, water. So we all know the formula for water is H2O. And we understand because we talked about why two hydrogen bond with one oxygen. Okay? Because the oxygen is missing two electrons. Each hydrogen has one extra electron, so two hydrogen can bond together with an oxygen, and everything is happy. So the way you can do this simply is by writing what you do. This is called the crisscross method. Okay? So if you remember the valence number, the oxidation number for hydrogen is +1. Each hydrogen is +1. The oxygen is what? -2. Okay? And so when those things all bond together, they equal out to a net charge of 0. So to do this, what we do is we write our two elements that we are interested in, how they're combining. We're going to talk about metals and nonmetals a little later. We write the metals on the left, the nonmetals on the right. Okay? What we do is we write the oxidation number above them. So hydrogen's +1, oxygen's -2. And then we just sort of crisscross them. We take the 1 and bring it down to go with the oxygen. We take the 2, bring it down and make it the subscript of the hydrogen. And then we have our formula. H2O1. So again, when we write in chemical symbols, we don't write the 1, we sort of ignore it. Okay? We assume it's 1 if there's no subscript. And so we have H2O. We don't write the 1.
Why is it not -1?
We don't use the symbols, so we don't use these signs. We just need,
So the negative
but we have to have a positive and a negative. But then once we're doing this little crisscross thing, we ignore the sign. Yeah. Okay. So for example, if we have sodium and phosphorus, so you're going to need your periodic table here for a little while. If you don't have it out, take it out. So the metals on the left, that's sodium in this case. The nonmetals on the right, phosphorus. Tell me, what is sodium's oxidation number? Raise your hand, please. Sodium's oxidation number.
11.
Raise your hand, please. Left.
Tis
Two.
+1.
+1. What's phosphorus's oxidation number? Raise your hand if you know that. Luke?
-3.
-3.
Wait, whoa. Question, how did you get -3?
Let's find phosphorus over on the right.
Yeah.
It's
Missing 3.
its number of electrons, yeah, it shows 5.
It needs 3.
So its oxidation number is -3. It's missing 3. Remember we did that yesterday? To get up to 8. So then we just take our numbers, crisscross them down. 3 comes down here with the sodium, the 1 goes with the phosphorus, and the compound they form is Na3P. 3 sodium atoms each contribute 1 electron to fill in those gaps in the phosphorus.
Sodium, phosphorus.
Okay?
I don't
Calcium and sulfur. What is calcium's oxidation number? Raise your hand. Okay.
-6.
No?
Oh wait, oh, never mind. +6.
Nope. Evan?
2.
Plus or minus?
+2.
+2. It's 2 extra electrons in that outer
Oh yeah,
shell.
because it has an 8 right there.
How about
Okay.
sulfur, Gaetano?
-2 or -2?
Okay, minus 2. So again, we do our little crisscrossy thing. Ca2S2. And often too, we will simplify
Because
the numbers.
it's two.
Okay,
that's
so one card, so we can simplify that because they're both, divide both by 2 and we get CAS.
Like, could we always say kind of like, is that because we have a positive 2 and a negative 2 and those equal 0? So
Yes, see, these are always, yeah, so 3 sodium gives you +3, 1 phosphorus gives you -3, and they balance out.
Okay, so Mr. Jost,
Yes.
if you do gallium and sulfur, you get gas.
All right, so look at these, beryllium and fluorine. So first, you gotta find their symbols, beryllium, Be, fluorine is F. All right, so let me call on some people here. Matt, what is beryllium's oxidation number?
2.
Okay, plus or minus?
One.
+2. How about fluorine? So the metals on the left here, it's also the left side of your periodic table.
7. Is it minus
What-
1?
What's its oxidation number?
Oh, minus 2.
Nope.
Minus 1.
No.
minus 1?
It has 7 in its outer shell. How many is it missing?
Oh, 1.
1.
Oh my
So what's its formula, Matt?
Minus 1.
B1 F
Be1, F2.
Beth 2.
That too.
Magnesium and oxygen.
It's almost your mom's name.
That's good.
All right, Julia. Magnesium. What's its symbol?
MN.
No, that's actually manganese.
Oh,
Oh.
it looked like it.
Yeah, they're 2 different elements.
Manganese. Oh, MG.
Mg.
Yeah.
What is its oxidation number, Julia?
Minus 2.
No.
I mean plus 2.
+2. Oxygen, Julia?
Oh, I see it. Minus 2.
-2. So what's the formula when these form a compound? I'm asking Julia.
M2O2.
Mg2O2, which we can then simplify even more.
MgO.
Gaetano, barium, what's its symbol?
Where's there?
Ba,
And it's
Back.
+2,
it's +2. Chlorine,
chlorine, Cl,
yep,
and -1.
-1. What compound do they form?
B, BaCl2.
Correct. BaCl2. All right, so you guys have asked a little bit about naming, and naming of compounds it can be very, very complex. And there are often multiple ways of naming a compound. We don't need to really get into the details, but we'll talk about some of the basics today. So usually when we're naming compounds, simple compounds that are made of metals and nonmetals, the first name is the first element. In the second element, we add I to the name.
That was height.
So NaCl. Na is what?
Sodium.
Sodium.
Sodium chloride.
Cl is chlorine, but when it forms a compound, we call it chloride, sodium chloride. We often can name compounds using Greek prefixes as well. Okay, the Greek prefixes, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So carbon, so CO2, first element is what?
Carbon.
Carbon. Second element,
Oxygen.
oxygen, but we changed the name to
Dioxide.
oxide. And then how many of them are there?
2.
2.
So it's like carbon dioxide.
So it's carbon dioxide. Okay. Now, There are also some sort of special groups of atoms that sort of behave like one element, and they're called radicals or polyatomic ions. And for these polyatomic ions, you can actually look them up on this chart I'm about to give you. This chart is sort of like your periodic table. On your test next week, which I'm thinking is Wednesday, you can use this chart along with your periodic table.
Wait, so Mr. Duras, the name of the compound that we made in our bell work would be dimagnesium trisodiamide?
No,
Trisodiide.
it was nitrogen. Yeah, but sometimes we name them different things. So when we look at this list, so the things on this list, they're groups of atoms, they're molecules, but they sort of act as one element. So we can use them in the same way to figure out the formulas of different compounds. So they're called radicals or polyatomic ions. It's a group of atoms that acts as a single atom. Okay? They have their own oxidation number, they have their own formula, and you just look them up on that chart. So if we look at an example, we also, when we're writing them, we keep them in parentheses to show that they're acting as one unit. So if we have nickel, and what is PO4? What is the name of that radical? Phosphate. Okay? Nickel, phosphate. So nickel, if we look at it on the periodic table, what is its oxidation number? Nickel, what is it? Minus 3?
Oh, yeah.
No? Don't think so, is it?
It's like.
Nickel.
Um,
And I? Where is it?
+2.
Plus 2?
Yeah.
Oh, I was looking at nitrogen.
Yeah. So it's plus 2. Phosphate is PO4.
-3.
That one you look up on your radical chart. What is it?
-3.
Minus 3. Again, here's do our little crisscross method. And what we get
That's confusing.
is Ni3. 3 comes here. The 2 comes here outside the parentheses.
PO6.
Okay, so nickel, phosphate, Ni3, PO4 in parentheses, 2. Here I have 2 radicals combining to form a compound. What's this one called, NH4?
Hartford.
New Hartford.
Ammonium.
Ammonium.
Oh, it's different.
What is CO3?
Carbonate.
Chlorate. Carbonate.
Carbonate.
CO3 is carbonate.
Oh.
What is the oxidation number of ammonium?
Plus
+1.
Plus 1. What is carbonate?
-2.
-2, yeah.
Minus 2. Crisscross them. I get NH4 2, parentheses, CO3. Next.
Wait, how come the numbers when they're plus and minus 2 are on the top, but when you cross they're down?
Because the plus and minuses are the oxidation numbers. When we use them to form the compound, they're just telling us how many of each element or how many of each radical there are. So they sort of mean different things.
We're gonna have to know how to name those.
Not really, no.
compounds for the test?
No,
When's our test?
Wednesday. So let's look at these. What would you call this?
Sodium chloride.
Sodium chloride.
Sodium chloride. How about this?
Magnesium oxide.
Raise your hand, please. Magnesium oxide. The next one?
Magnesium.
Lou?
Magnesium bromide.
Yep. Now we could be more specific, call magnesium dibromide. we wanted to. Sometimes we do, sometimes, that's why I said sort of naming these compounds. There's a lot of variation there. How about Li2S? Raise your hand. Julia?
Lithium, sodium. Wait, what? Oh.
Lithium,
Yeah, lithium sulfate.
So,
ask him Julia. Sulfide.
oh, I thought that was some.
What did we dilithium sulfide?
You could be more specific, yep. How about BeSO3? Glad?
Wait, it's beryllium trisulfide, sulfite.
Not trisulfide, just sulfite. Beryllium sulfite. Where did you get sulfite?
Because
Where do
it's
you-
mad.
Where do you find that, Gabe?
It's on the radial, or the radical
It's
chart.
on the radical chart. SO3 is a radical. Sulfite. How about AlBO3?
That was way too confusing.
AlBO3. Jackson?
It is, okay. So AI.
Al.
Aluminum, oh, Al. Aluminum borate.
Yes, aluminum borate. And then this last one, CaCO3. Karina?
Calcium carbonate.
Yes. How do we know that it's not calcium cobalt? CO.
It's capital.
Because it's
Capital.
capitalized.
Yeah, because it's capitalized.
Just calling it
Cobalt is a lowercase o. All right, any questions about this? All right, we'll do some more practice with it tomorrow.
Do they have any homework?
No homework.
Wait, is it true that your SCI7 classes never get homework?
I wouldn't say never, but rarely.
Favoritism.